Hello and welcome back. Another day, another panel, and today it's really microprocessor panel. So we're going to check the microprocessor panel. We are replacing all the capacitors and put the chips onto a socket. What we have seen so far during the analysis and when we reconnect everything, that the tape deck CPU is working. It seems to be working. We have seen the display has shown the default screen, which means that the serial bus is working. When we accidentally clicked on play of the cassette instead of the CD player, we have seen that the tape mechanics reacted. So it seems to be fine, although it freezes from time to time, and this might be because of the software. It might happen that when the CPU sends a command and the tape mechanics is not able to execute it, there's no error routine in the software, and then it's waiting for a signal which never comes. Might be. I can't tell this exactly because I do not have the source code, and we will see if we are finished and we are connecting the tape mechanics with the new belt, if it's then working or not. Before, however, we can do some basic checks. And this would be, for instance, if the microcontroller gets its power, if the reset circuit is working. That's important, because I have seen if the reset circuit is sending two signals like a double click on a mouse, the CPU hangs. I can show you this with the test circuit, and we have a look at the test circuit when I get the CPU out. Okay, what do we need to check some basic functions, features? We do not need to connect the board to all the others. It's enough to get 12 volts into the plug. And for this we need pin 3 for the ground and pin 8 for 12 volts. Let me connect this here. Okay, it's connected, and then let's use our oscilloscope. You can hear it in the background, the noise. Okay, you're better off when you print the service manual page of it. Helps you to see where all the pins are going. The first thing we are going to check, I do not expect any issues right now because, as I said, it should be working. We've enabled 12 volts. Let's see what's here on the pin 40 of the tape deck CPU. We do have 6.2 volts. Important is the reset circuit. As I said, it should only be one. Okay, so this is working fine. So we can have a look at the clock. Go to pin 38 and we can see it's 5.88 megahertz, and the clock also powers the CD CPU. But what else can you check? For instance, pin 29, there should be a signal, an oscillating signal. It's also working. We can check, all of the pins should have a spike. They're using it to, and let's see, here is, this one is for the cassette state sur. Come back here. Well, the CPU is fine. Okay, so what we are going to do now is replacing all the capacitors and put the chips on the socket. Fine. I prepared all the capacitors. We are not going to need any audio grade capacitors here. What I really need is my coffee. It's early in the morning.
I'm going to bend the wires to move it a little bit to the side to get space for a heatsink for the voltage regulator. Do not heat up the pins for too long, otherwise you risk to destroy the chip. Also give it some time to cool down. Here I check if all the pins are free, so that we can easily remove the chip without breaking a pin. I'm now cleaning all the pins and ensure that they are all straight.
Let's make a small test. And again, using external power supply. I'm gonna switch on, and we can see it is working. So that's all. That is the whole thing. It was just a software bug. Be aware, if you switch on, if it's doing this, then you need to take care of the record lever here. Just move it out and then it stops. Test if the keys for the CD player are working. Since the tape deck CPU is working, we'll enable here and let's press play on the CD player. Well, see, it's trying to read. It still cannot read the table of content, but the keys are working since the microcontroller of the tape deck is working.
That means we can solve this easily by checking the default states of the tape mechanism. And therefore we need to figure out what the CPU is trying to do in a first step. And the CPU is trying to set the tape mechanism to this default state, which means that the head is on side A, the slide servo is down, and the record mode is disabled. And if one of those commands fail, the CPU hangs, waiting for the tape mechanism to complete the command, and then the whole machine becomes useless. And the solution is quite simple. We're going to set the tape mechanism manually to this default position, and we're going to check if all the switches deliver the correct signal. They might be corroded and need to be cleaned, so this needs to be checked. And then the CPU should work.
I'm now going to show you the PCB I created for testing the microcontroller of the tape deck. For this I'm using the CPU from unit number 2, which is not working, so that we can see the results. I've also printed the results and the outcomes from the datasheet. Usually the channels should cycle. If not, they are not working. We're using an external power supply, 5 volts, 100 milliamperes. Enable and try to save the results of the measurement. Okay. And for this CPU, in the first 500 milliseconds it looks good. There's a cycling on all 4 outputs, all 4 ports, but then only port 2 is high and all the others are low. That's not mentioned here, it's just mentioned all others, bad part. So at the beginning it looks good, and from time to time it is running, or at least it's doing something. Let's save the results. In this case we have a cycling on channel 1, 2, 3. Let's get a single step. Well, that looks good, but it's not working all the time, and that's the problem. Try again. Oh. No, just click reset and it's not working again. It maybe needs a long reset. After 500 milliseconds it's gone. Yeah, this one is not working. And That's why I started to replace it with an AT1284P. So that's how it looks like if it's not working. Otherwise you will see recycling, as we have seen for a short time. I don't know why it is. At the very first test I have done with the CPU, it pointed out it has a bad ROM. It showed exactly this one. This result here. I'm going to publish the keycard files for this board. My 10 mega ohm resistor is a little bit too big. Go for a smaller one.
Okay, so let us summarize what was the issue. It was quite simple and easy to solve. The tape deck CPU sent a command to the tape mechanics, and because of a weak belt, the tape mechanic was not able to execute the command, and the CPU was waiting for the tape mechanics to be finished. As a software engineer, I would say this is a bug. This should not happen because it also makes the CD player useless, because the keys play, stop and pause are controlled by the tape deck CPU. Back those days it wouldn't be easy to update a software. There was basically no internet in the 80s, but this is something for a modification. And we're going to consider the fact that the tape mechanic would not be able to execute something and then show an error instead of freezing the whole system. So if your sound machine shows the same issue, that does not mean it has to get expensive. Just get a new belt might solve your problems. You can find such a belt on eBay, hopefully. If not, I'm going to add the dimensions of the belt in the comments. You can also find this on my website. And, well, we've got it solved. The tape mechanics is now working, and also the CD player is able to start and stop. Which means our next step is to take care about the CDM2 drive to ensure that everything is working. We're going to clean it up, exchange and replace the capacitors. Maybe we can set the currency for the laser, and then the next step would be the controller panel, and let's have a look why it is not able to read the table of contents. But that's basically all for this episode. Thank you for watching and see you next time. Cheers!